Welcome students. From testing of hypotheses, today we are concentrating on the another test which is used for qualitative data, and that is nothing but the F-test. So this test is used in order to compare two variances, and this is denoted by V1 and V2. So ratio of the two variances is nothing but the F-statistics, and this is firstly given by the Fisher. You are familiar with this name, that is Fisher's diagram for designing of a experiment we have studied, where randomization, replication and local control we came to know. So the F name is given in the memory of Fisher. Again here null hypothesis is variances are equal, and that's why V1 and V2 equal, thus the ratio is 1. And in alternative hypothesis they are different, so the ratio deviates from unity. And this EF test is based on two assumptions. One is samples are normally distributed, and another samples are independent of each other. Now we'll go for the table which can give you more idea about the decision for the application of F-test. There are again one-tail and two-tail F-test. Depending upon that, hypothesis varies, either null or alternative hypothesis we are using. So for one-tailed and two-tailed, these type of hypothesis we have to use. And after that, test statistic is for one-tailed test. Here S2 square divided by S1 square, and here you can observe that S1 square divided by S2 square. This is depending upon the hypothesis, either your sample 1 is greater than or equal to sample 2 in null hypothesis, and in alternative hypothesis the sample 1 is less than the sample 2. Like that we have to consider again the different hypothesis. So depending upon that test statistic may vary. And if there is a two-tailed test, then again null hypothesis that two samples are equal, and in alternate hypothesis they are not equal. So for that we have to use this formula. No doubt that it is the ratio of variances, but larger sample ratio is as a denominator and smaller sample as the numerator. Obviously degree of freedom is for sample 1 n1 minus 1, sample 2 n2 minus 1, and either rejection depending upon the values we will get from the table. Null hypothesis we are going to reject if the value, calculated value, is greater than the tabular value. And here in two-tail hypothesis we can reject the null hypothesis if the calculated value is greater than the tabular value. Now we'll go in detail with one example. Here in the example with two different sample having variances and their sample size they have given, just we have to do the two-tailed F-test. So first null hypothesis, another alternate hypothesis. Null hypothesis states that there is no difference in variances, and in alternate hypothesis there is a difference in variances. From this null hypothesis, just we have to calculate the F value by dividing the highest variance by lowest variance. Note that highest variance is at numerator and lowest variance is at denominator. Okay. Now explanation for this, why the largest variance is on top and smallest is at base. Because largest variance on top will force the F-test into a right-tailed test, and this is easier to calculate than the left-tailed test. This is why largest value or the highest value at numerator and smallest value or the which is at the denominator. Okay, so by putting this value in formula, V1, which is largest for variance V1, it is largest than the V2. So 109.63 divided by V2 65.99. So we'll get the F statistic calculated value is 1.66. Next to this, degree of freedom, as like the t-test and the chi-square test. Here the sample 1, okay, its size is 31 and for 2 is 21, and degree of freedom is obviously 31 minus 1 for the sample 1 and 21 minus 1, that is 20 for the 2, which is numerator and the denominator. Like the chi and t test, use alpha is 0.05 if it is not given, because that is not stated in the question. As we have to use this data for the two-tailed test, we have to half this, and that's why 0.05 it will be 0.025. So from the F table, okay, and the significance level is 0.025 with our degree of freedom 30 and 20. Obviously highest degree of freedom at numerator and the lowest at the denominator, and this value is 2.20. How it comes, I will show you this table. So highest value degree of freedom, this is the F table for 0.025 two-tailed test, 30 and 20. This value comes 2.20. okay, so from this, just this is we will get this tabular value, and in the last slide we have received the calculated value. Now our final step is to make the decision from all this. So comparing all these values from the tabular and calculated value, what we have get, calculated value is higher than the tabular value. Okay, what is your calculated value? It is 1.66 and tabular value is 2.28. So what we have observed, it is, that is calculated value is less than the tabular value, so we cannot reject the null hypothesis for this two-tailed test. So this is about the F-test, which is used for comparing the ratio of variances. This is about the F-test, and this is the end of different tests we are using for the testing of hypothesis. One we have studied t-test, another one chi-square test for genetical experiment or breeding experiment, and F-test for the variances. Thank you.